All right, so on the previous lesson, we were talking about position vectors where the initial point is the origin, 0, 0, and the terminal point is actually your component form. Now, what can we do with vectors that are not actually position vectors? Can we find a component form for them? And the answer is yes, of course we can. Okay, so any vector that has an initial point x1, y1, and a terminal point, x2, y2, can be written in component form using this formula right here. V is your vector name. You can do x2 minus x1, and that will give you the component form for x. And then you can do y2 minus y1, and that will give you the component form for y. Now, the component form for a position vector is the terminal point because the initial point is 0, 0. All right, but if you have just a regular old vector out there, if you want to find its component form, you have to do x2 minus x1 and y2 minus y1. Now, you might be asking yourself, can I do x1 minus x2? The answer is no, exclamation point, all caps, bold, underline, everything that I can possibly say to get you to pay attention to this, okay? So when you're finding the component form for any other type of vector that's not a position vector, you have to do the terminal minus the initial. Terminal minus initial. And I even wrote that down right here so you could see it. Terminal minus initial, okay? T minus I, T minus I, okay? So, and that will give you the component form for all of our other vectors that are not position vectors. All right, so looking at number 7, it says give the component form for each vector. We have CD, and I know you can't see it very well, but there's our little arrow. So if we have CD, the vector C doesn't have the arrow above it. So that means that C is my initial point. So this is my initial point. D has the arrow above it. So that means D is going to be my terminal point. So if I'm going to find the position vector for CD, then I'm going to have to do X first. Terminal minus initial. And then Y, terminal minus initial. 6 minus 3 is 3, and 3 minus negative 5 is negative 2. So this is the component form for vector CD. Notice the component form is not the terminal side this time, okay, because this is not a position vector. These are just your directions that will get you from initial to terminal. So from 3, 5, we can go to the right 3 and down 2, and we're gravy. Okay? You can do number 8. Now for 9, 10, 11, and 12, you're asked to find the component form, you're asked to find the magnitude, and the direction angle. So you're going to do component form for this. Remember, it has to be terminal minus initial. Then you're going to do the magnitude. You can no longer do the square root of a squared plus b squared because now we have 2 points. You have to go back to the distance formula. And then the direction angle is still going to be your component form b over a. Okay, and use the rules that I taught you for quadrant 2, 3, and 4. Now looking down here, okay, looking at equivalent vectors again. In the previous lesson on Tuesday, we learned that in order to determine if two vectors were equivalent, their magnitudes and their slopes have got to be the same. Well, fixing to learn another way now, which is a little bit easier. Vectors are equivalent if and only if they have the same component form. So, use the component form to determine if vector AB and vector CD are equivalent. So, change vector AB to its component form. And then take CD and change it to its component form. And once you do that, if AB and CD have the same component form, then they are equal vectors. If they don't, then they are not equal vectors. Okay, so I want you to complete this sheet and send me your solutions. Y'all have a great day.